Hi, today we're going to move on in our unit and we are going to look at writing what's called a two-column proof, learning more properties, theorems, and just continuing to practice this idea of proving items. So let's start with some definitions. Actually defining a proof. So a proof is a logical argument that shows a statement is true. It's a logical argument that shows a statement is true. So in math, or really in anything, there needs to be a logical thought process to get from, A to Z, and you need it to be able to be replicated every single time. Okay, so like think anything mechanical, like a car, or anything medical, like a surgical procedure. You want to know that it has thoroughly been studied and proven through a logical thought process that if you do these steps, this will be the outcome. All right, a two-column proof. This is the format we're going to spend the most time on. A two-column proof would be numbered statements and reasons that show the logical order of an argument. So it's more of a format. It's in two columns, so therefore it's called a two-column proof. There are proofs called paragraph proofs, flowchart proofs. It's just a way to show a logical thought process. And then the last definition would be theorem. A theorem is a statement that can be proven. So a lot of times we're going to be learning a lot of theorems. Sometimes we'll just take them for what they're worth and we'll use them in our proofs. Sometimes we'll actually take a theorem that we already know is true, but we will replicate the proof, just again to continue to work on what a proof is. Okay, we do have a few more properties. We really have three more. And so, actually, let me backtrack here. This is from yesterday, or the previous section. So in the previous section, we learned the reflexive property of equality, the symmetric property of equality, and then the transitive property of equality. So we're learning three more today, but they're not that much different. Instead of being called the property of equality, we're going to have a congruent symbol. So they're going to be called properties of congruence. Let's see. I'm going to maybe just highlight the word congruence. So in this chart or this table right here, there's just multiple examples, but there's really just three more properties. We have the reflexive property of congruence, we have the symmetric property of congruence, and we have the transitive property of congruence. They do the same thing. So like for example, in the previous section, the reflexive property is just an item equaling itself. Well, the reflexive property of congruence is just an item congruent to itself. So like this whole section right here talks about segments. So it would say segment AB is congruent to segment AB. That's the reflexive property of congruence. Here's an example down here with angles. Angle A is congruent to angle B. So you've got this congruence symbol in them versus an equal sign. Symmetric property I mentioned before was like the switching property. So the property of equality, A equals B, then B equals A. Well, in the congruence, they'll be congruent. So if segment AB is congruent to segment CD, then segment CD is congruent to AB. So the order switches. Same thing for angles. Angle A congruent to angle B, then switch them. Then angle B is congruent to angle A. And then we have a transitive property of equality where it's like you're transferring that congruence. I'm sorry, I said equality. I meant congruence. So if segment AB is congruent to CD and segment CD congruent to EF, then segment AB congruent to EF. Now, one big difference here too, I want you to notice, when we use congruent symbols, we are setting geometric names congruent. So like this is the name of the segment, not the length. This is the name of the angle. It doesn't say M in front of it, measure of. So when we're dealing with, we show things are congruent by showing their names versus the ones that are equality. There's no bar above it. So that says length of, measure of angle A. that type of thing. Okay, so we'll have like the names of the shapes whenever we're doing properties of congruence, and then the just like the numbers being equal for the other one. Okay, let's do some identifying. Okay, name the property shown. If angle R is congruent to angle T and angle T congruent to P, then angle R is congruent to P. So I've got that kind of transferring of equal or congruence. So this is your transitive property of congruence. Transitive property of congruence. Okay, transitive property of congruence. So again, it wouldn't be a property of equality because it is not an equal sign, it's a congruent symbol. Segment NK congruent to segment BD, then segment BD is congruent to segment NK. Okay, they just switched. So that's the symmetric property of congruence. And if you want to shorten these a little bit, you can maybe shorten property of, and if you want to use the congruent symbol, you can, instead of writing the word congruence out. You can do the same on equality. You could do symmetric prop of equal, that would be okay. Okay, segment CD is congruent to segment CD. It's just the same thing back. That's your reflexive. Reflexive property or abbreviation property of congruence. Okay. And then if angle Q congruent to angle V, then V congruent to Q. They are switching. So that's your symmetric property again. Symmetric property of congruence. Okay, so they're the exact same as the other day. It's just we have a congruent symbol. Okay, so I'm not really sure I'd call them three new properties. You just want to be aware of that last part. Okay, let me see where we are at. All right, let's go over this section right here. I don't know if I can get the rest done in one video, so I might stop after this. This concept summary is a really good way of setting up what we're doing with proof. So let me read through this at the top here. It says, in a proof, you make one statement at a time. So we have them numbered 1, 2, 3, and so forth, until you reach the conclusion. Because you make statements based on facts, you are using deductive reasoning. Usually the first statement in reason pair you write is the given information. So here's an example. This is actually a proof of the symmetric property of angle congruence, or we can just call that the symmetric property of congruence. So normally you are given some information and then you are told what to prove. So we are given angle 1 is congruent to angle 2, okay? And a lot of times you have a picture or you would draw one. So look at the format down here. These are the two columns. So this is a 2-column proof. We'll make a big T chart and label statements and reasons. And then look at line 1 is repeated of the given. So I just want to copy down the given and the reason is given. And then from there, you are either noticing relationships on pictures or we're using things that we are learning along the way. So like we're going to talk about these couple here today. So angle 1 is congruent to angle 2 is given. Number 2, the measure of angle 1 equals the measure of angle 2. So let me talk about the reason and then we'll talk about why it's called that. Definition of congruent angles. So I'm going to highlight this because we will continue to work on, this is a definition you will see show up quite a bit. So if you were to tell me, or I were to ask you, what does it mean if angles are congruent? Well, hopefully you would say, well, it means that their measures are the same, or it means that their measures are equal. So line 2 really just says what the definition of congruence is. So we would write that out as our reasoning. It's just the definition. Okay, so we'll see that show up a lot. Number 3, measure of 2 equals measure of 1. So do you see how they switched around? So this is the symmetric property, but it's an equal sign, so of equality. So that's the symmetric property of equality. And then step 3 to step 4, we went from the measures being equal back to the angles being congruent. And then that's another definition. That is just the definition of what congruence is. So that is called the definition of congruent angles. So over here on the left, notice lots of symbols. So these are items based on fact deductive reasoning. Over on the right are all the names of everything. So one thing that will help you, if you go to the end of your notes packet, I have just listed out, these are just postulates and theorems, if you go on to the next page too, that we are studying. So as you go through this, this might help you as you're doing a proof to just look over it, and something might jump out at you as, okay, yeah, we've talked about this before, this is what it's called. Okay, I think I'm going to stop this video here, so go on to the next video and we will run through, we really just have 2 proofs, but I really want to spend my time and go over them slowly with you.